Alright, this is a quick application problem to your rational functions from section 8.2, and it says the senior class is sponsoring a dinner. The cost of catering the dinner is $9.95 per person plus an $18 delivery charge. Write a model that gives the average cost per person. Alright, so we want to write an equation, of course, that will represent this average, and we know that when you average something, you're going to divide by how many things you have. In this case, it's people. So x, I'm going to define x off to the side here. X would be the number of people. Alright, so write a model that gives the average cost per person. So I'm going to use C for cost, and I'm going to do C of x. So it's going to be a function of function for cost for the number of people that attend, and that's going to be $9.95 per person. So that's times x plus an $18 delivery fee, and that's not per person, so there's no x there. And then it's an average, so I'm going to divide by x. So again, $9.95 per person, and plus $18 not per person, and then you divide the whole thing by x to get an average per person. So that would be part A. Part B says graph the model and use it to estimate the number of people needed to lower the cost to $11 per person, and circle the point. So what I did was I just kind of picked some random x values, 5, 10, 15, 20, and then 900, just to see what would happen. So far extreme, as you know, with the section we look out, our graphs approach asymptotes. So first and foremost, the horizontal asymptote, and I'm just going to kind of state this off to the side, but our horizontal asymptote, because I have the same degree divided by the same degree, right? I have x divided by x. I'm going to divide out the leading coefficient. So 995 divided by 1 is 995. So my horizontal asymptote I know is going to be 9.95. So right off the cuff here, if I kind of approximate, I'm just obviously going to kind of put that at 10. There's where my horizontal asymptote will be. Other things you might know, of course, if you solve the denominator, that's pretty easy. X equals 0 will be a vertical asymptote, so that would just be the y-axis if you wanted to draw that in. But of course I only really care about the positive graph because I'm graphing, or x represents number of people, so I don't really care about the negative part. So I'm either going to have a hyperbola branch here or here, and we're about to find out. So I would suggest, this would be a calculator question on an exam, and for your homework, of course, you'd probably want to use your calculator. So I would put this in your calculator. Make sure you, when you type it into your y equals, put the numerator in parentheses, and then divide by x. So go ahead and pause the video and type that into your y equals. And then after you do that, if you go to your table and take a look at the following x values, and then we can just kind of fill those in. So I really didn't leave myself much room, but when x is 5, I'm actually just going to write out the points. When x is 5, y is $13.55. When x is 10, y is $11.75. When x is 15, y is $11.15. When x is 20, it's $10.85. So as x is getting bigger, our amount per person is decreasing, which makes sense. And finally, my large 900 value has a $9.97 average. So it's approaching $9.95, of course. So if I graph these, not that I'm going to graph these, perfectly, but you can see that at 5, it's like, 13-ish dollars, and then at 10, it's about 12, and then at 15 it's going down to about 11, etc., etc. So it's working its way out as follows. So C says describe what, oh, I'm sorry, I didn't finish the question here. It says estimate the number of people needed to lower the cost to $11 per person. So graphically, and I'll just change the color of my marker here. If I go to $11 per person, I can kind of estimate, well actually if I look at just my points here, between 10 and 15, it's going to be about, you know, in between 11.15 and 11.75, but because I can't really tell from my graph, I'm going to plug in 11 for my cost per person, and then I can just do the algebra because it's really not bad algebra. So I'm going to multiply the x over to the other side, and then I'm going to subtract 995x, grab my x there, from 11x, and that's 1.05x equals 18, and then if I divide, x is approximately 17.14. Well, I can tell that when x is 17.14, which again would be in between these two values, that yes, it's going to approach $11 per person. Oh, I'm sorry, in between these two. Wow, 17 is in between these two. And so that's going to approach $11. Then part C says, describe what happens to the average cost per person as the number attending increases. And I really already said that, but as x increases, the number of people increases, the average price per person approaches the $9.95. Your asymptote.